Lesson 1, Parameter versus Statistic. We are entering a really big important unit in Unit 5. This is the point in the class where we start doing our most sophisticated, but most interesting and real-world applicable problems. After this lesson, the whole rest of the unit will focus on this skill of hypothesis testing, which will make the other 4 lessons very similar to one another. This lesson is uniquely different, as I decided to add it just to get you prepared for hypothesis testing. It's such an important skill that we spend the entire rest of the semester on that I want to make sure we really understand what we're doing and some of the key language and notation that we need to know. One of the core concepts of the subject of statistics is to use what's called a statistic to make claims and predictions about the concept of a parameter. So I thought it was important to be able to spend a lesson understanding what a statistic and what a parameter are. A parameter is a measurement describing an entire population. The easiest way to remember this is P and P. A parameter describes a population. This is really what we want to know about. I might want to know the average weight of a male or the average age of an American. The problem is, to get a parameter, you need a data value from every member of the population. So if, for instance, I was trying to describe a population of 3 billion cicadas, I would need to collect data from all 3 billion cicadas. That's not very realistic. And that's where the idea of a statistic comes in. A statistic is a measurement that describes a sample. Again, the easiest way to remember this is the alliteration. S for statistic and S for sample. It's much easier to attain a sample set of data rather than an entire population set of data. So one of the key purposes of statistics is to be able to collect a sample and use it to describe a population. And that's what we'll be doing in our future lessons. So let's get some practice deciding whether or not some measurements are statistics or parameters. Our first problem says it's known that 10% of all the players on the Chicago Cubs have earned a college degree. Well, this 10% is describing all of the players. That word all means that we have the entire population. Well, if we're describing the entire population, P for population, P for parameter. So this 10% was a description of the population, making it a parameter. In the next problem, we're told that 4% of 100 Major League Baseball players surveyed say that they have earned a college degree. Well, there's a lot more than 100 baseball players in the major leagues. So this is just a sample. So this 4% is describing a sample, and that means it's a statistic rather than a parameter. If you describe a population, you're a parameter. If you describe a sample, you're a statistic. Now, when we get into hypothesis testing, you're going to have to trust me here. Notation, it becomes extremely important. In one problem, you'll be dealing with both the notation for a parameter and the notation for a statistic for the mean. And that can get really confusing if you don't know which is which. This first symbol is pronounced mu, and it represents the parameter mean. So that means the mean of a population, or the average of a population. The second symbol, x bar, is a statistic that represents the mean of a sample, or the average of a sample. So both of these symbols represent the mean, but one represents a mean of a sample, and one represents the mean of a population. So in this example problem, we're told that the heights of 10 randomly selected Glenbard East students are listed below. And they ask us to find the mean, and we're going to use Desmos for that, and to use the proper notation. So here's our set of data. There are more than 10 Glenbard East students, so these 10 randomly selected students represent a sample. And since it's a sample, we want the statistic notation of x bar. So I'm going to pull up Desmos and create a table. I'm going to put all 10 of these values into that table under x1. Now that I have those 10 values entered, I'm going to go to Functions, Statistics, and Mean. And I'm just going to put mean x1, which Desmos tells me is 66.2. So I'm going to write this with the proper notation using x bar, since it's a sample mean, and saying x bar equals 66.2, that number I got on Desmos. And that's our final answer for this problem. Next, we're going to get introduced to a very important topic called proportions. This is hit heavily within hypothesis testing, and it's not something we've really dealt with yet in this class. A proportion is a measurement that states the percentage of the population that meets a certain criteria. We use decimal percentages for this, And it's just basically a measurement of what percentage of the population does something that you're looking for. So maybe it's a question of what percentage of the population has brown hair. So for the parameter, you can use the fancy notation, but it's really just a p. And we just call it p, and it represents the population proportion. So what percentage of the entire population meets a requirement. This symbol here is pronounced p hat. This is a statistic that represents the percentage of the sample that meets that requirement. This is a statistic because it describes the sample. So let's do an example and make sure we use the right notation. We're told that 63 out of 221 randomly selected East students state that they believe the school should enforce the dress code more strictly. And we're asked to find the sample proportion using the correct notation. Well, we know there's more than 221 students, and they tell us to find the sample proportion, so the notation we need to use here is p hat, the statistic, not the parameter. And there's nothing fancy we have to do here because it's just a percentage. We're just going to take that 63 and divide it by 221, which my calculator tells me is 0.285. So approximately 29% of students believe that this dress code should be enforced more strictly. And that would be our final answer. Finally, we're going to talk about standard deviation. Again, there's two symbols here. This first symbol is pronounced sigma and represents the parameter, so the standard deviation of the entire population. And the second symbol is just pronounced S, and it is a statistic that represents the standard deviation of a sample. So now they ask us to find the standard deviation of the sample of 10 students' heights. Again, we're describing a sample, so we're going to be using the statistic, the S. And again, we're going to go back to Desmos for this. You do need to be careful here. We're using the same data as we used in the last problem. But when we go to do our calculation, you might notice that there's two things that say standard deviation. One says STDEV, and one says STDEVP. Well, standard deviation has different formulas for whether or not you're calculating the statistic or the parameter. When you see that P at the end of the formula, this is actually the wrong formula. This is the formula for the parameter. Instead, we want to use the formula that just says STDEV. And again, we're just going to type in X1 because that was the name of the list. And the calculator tells us that this is 4.61. And we'll cut off at that hundredths place, and this problem is over. In this lesson, we've learned about three important sets of notation: mean, proportion, and standard deviation. Each set has two different notations based on whether or not it's a parameter or a statistic. Remember that a population description is a parameter and a sample description is a statistic. If you came away with anything else, write that down now. Otherwise, we'll see you in the next lesson.